10. Today we're going to be graphing straight lines, but before we start with the new work, let's do a quick review of the fractions questions that we were doing last lesson. So question 1 wants me to simplify fractions by subtracting them. It's not an equation. So in order to do this, I'm going to need to get a common denominator. At the moment, I have a 7 and a 3 on the denominator, so I'm going to multiply those together to get 21. Then the 3 from the bottom of this fraction needs to multiply with the top of the first fraction, and I'm going to write that with brackets. I'll go 3 bracket 7x plus 2. Then the 7 needs to multiply with the top of the second fraction, so there'll be a minus sign from the question, and then 7 bracket x plus 2. Then I'm going to expand and simplify the top. 3 times 7 is 21x, 3 times 2 is 6, minus 7 times x, and then minus 7 times 2 is a negative 14, all over 21. On the top, I can collect 21x minus 7x to get 14x, and 6 take away 14 gives negative 8 all over 21. Moving on to question 2, this one's an equation because we have the equal sign. Because there's one fraction on either side, I can use the cross multiplication method. So the 5 will multiply with the top of the first fraction, like this, and then equals the 4 will multiply with the top of the second fraction. Then we expand. 5 times 5 is 25x. Then minus 20 equals 4x minus 20. Collecting up the x's, the 4x, I'm going to subtract that from both sides to get 21x minus 20 equals minus 20. Now that the x's are all collected on the left-hand side, we're going to do 2 steps to solve the equation. So first of all, I'm going to add 20. That will give 21x equals 0. And then dividing by 21, we get x is still equal to 0. Okay, so new work time, graphing straight lines. Straight into the examples. In question 1, we want to determine if the point minus 1, 4 is on the lines that we're given there. Now, to test if a point works for a given line, we want to sub it in. So in A here, I'm going to write down here that I'm going to sub the point negative 1, 4 into that equation. Now remember that the negative 1 is the x value and the 4 is the y value. That would give, so y is 4 equals minus 2x would be minus 2 times minus 1, so replacing the x with a minus 1 and putting the times sign in, and then plus 2 on the end. Now 4, I'm not trying to rearrange anything, I'm just trying to work out what each side of the equation is equal to see if the left-hand side does equal the right-hand side. So leaving the 4 on the left and calculating what's on the right. Minus 2 times minus 1 is 2, plus another 2 is 4. So the left-hand side does equal the right-hand side, so that means that, yes, the point is on the line. Okay, let's try it for part B. Same process. I'm going to sub the point negative 1, 4 into the equation. Again, x will be negative 1, y will be 4. So that will be 3x will be 3 times minus 1, plus 3y is 3 times 4, equals 2. Using your calculator or otherwise, let's calculate what's on the left. So we have 3 times minus 1, that's minus 3, plus 12 would make 9, and 9 does not equal 2. So instead of having 9 equals 2 written there, we're going to put a line through the equal signs saying that those two things are not equal, and if they are not equal, that means that the point is not on the line. So I'm saying no the point is not on the line. Question 2. Find the gradient and y-intercept for these linear relationships and sketch the graph. Now, you may use y equals mx plus b or y equals mx plus c. I'm going to use the new version, which is y equals mx plus c, but I don't really mind which one you use. So the gradient is whatever's in front of the x, and the y-intercept, which we're using the letter c, is the number that is on the end, usually the number without the x. So for this particular question, the m is going to be equal to the 2, and the y-intercept, which is c, is going to be equal to -1. To sketch that, and we do want it to be reasonably quick sketch, so we're going to limit how accurate and how much information is on here. We have our x and y axes. We always start with the y-intercept, which is -1. So straight to the y-axis, put a mark at -1, which is here. Okay, then we have a gradient of 2, and remember that a gradient is a rise over a run. So because it's just a 2, I'm going to make it 2 over 1, so that I can rise 2 and run 1. And you do that from the y-intercept. So rising 2 would be 1 there, and then rising up to a +1. So that's 2 spaces up, and then 1 to the positive side, making a positive gradient, would make that there at x equals 1. So those two crosses are where my line is going to pass through. So the line would look like that. I do need to make sure that the things that we look for when we're marking these questions is that the y-intercept is labelled, so I've got that down here at -1, and that I have correctly counted and need to label this second point, which will be at 1, 1. So I show that I have counted the rise and the run. Okay, let's do that again. Part B. This time the equation's not in the right form to read off the gradient, so I'm going to need to rearrange it to get y by itself. So let's start by leaving the 4y where it is, and move the 3x across to the other side, which will make that a -3x, and then the +4 on the end. Then I still need to get rid of the 4, which means I'm going to divide every term by 4. So it'll be -3 over 4x, and 4 divided by 4 makes 1. Now that my equation's in the right form, the gradient is going to be the -3 over 4, and the y-intercept is going to be the 1. And now we're going to draw it. So we always start, like last time, with the y-intercept, which is at 1. So we draw a mark there, and we label it with a 1. Then our gradient is -3 over 4. It already is a fraction, so I'm going to rise 3, 1, 2, 3, and run 4 to the negative side. So 1, 2, 3, 4 would be at -4. So that would put the point, the second cross, there. Draw a line to join it up. Make sure that your y-intercept is labelled and your point, which is -4, and this number here would be a 4, so -4, 4 is also labelled. Okay, so the way I was sketching in those questions, that's called the gradient intercept method for sketching straight lines. In question 3, we're sketching a straight line again, but we're asked to do this by finding the x and the y-intercept. Okay, so in this method, to find the intercepts, you want to start by subbing in when x equals 0, because that will find you the y-intercept, and then you also want to sub in when y equals 0, because that will find you the x-intercept. So if x is equal to 0, that would mean that -2 times 0 is just nothing, and we would have -5y equals 10. Then I can solve that by dividing by -5 to get y is equal to -2. Now, if I go to the second half of this question and I want to make the y equal to 0, that means that that part of the equation would be equal to 0, and I would have negative 2x is equal to 10. Solve that by dividing by negative 2, and x is equal to negative 5. Putting that information onto a graph goes like this. We know y is equal to minus 2, so we don't even have to count. We just go minus 2 could be about here. There's minus 2. We know that x is equal to minus 5. That can be about here. Not measuring anything. I'm just making sure that I have labelled in approximately the right places where those values would go and drawing a line between them. Often the x and the y intercepts of a straight line are the most valuable bits of information. So this is a very important way, perhaps more useful at times than the gradient intercept method that we were using in the previous question. Okay, question 4. Sketch each of the following. And we have y equals 4, x equals minus 1, x equals 3, and y equals minus 2 over 3x. Now the first three of those are just x equals a number or y equals a number. When you see that type of equation, these represent vertical and horizontal lines. So for a y equals equation, if it says y is equal to 4, that means you want to find on your y-axis where y is equal to 4, which I'll put there, and it just means that y is always equal to 4, and it would be a horizontal line going through that value. So that's, I'm going to put on here, that's A. Then for B, when it says x equals negative 1, that means we want to go to the x-axis where x is equal to negative 1, and there will be a vertical line going through that one. That is the answer for B. C is also an x equals, it's x equals 3, so 1, 2, 3. X equals means vertically going through the x-axis at the 3. When we get to part D though, it is different. We have y equals minus 2 over 3x. It's no longer just a number on the right-hand side of the equation. It has an x there. This will be a sloping line. So to sketch this, I'm going to do this using the gradient intercept method that we were doing earlier. The gradient is the minus 2 over 3, and because there is no number on the end of this, the y-intercept is equal to 0. So that means that this graph is going to start at the origin, but then it has a rise and a run of 2 and 3 in the negative direction. So from the y-intercept, I'm going to go up 2, 1, 2, and then 1, 2, 3 to the negative side, and that will represent my gradient. Draw the line going through. Make sure that your point is labelled, so that would be the point minus 3, 2. Okay, and that is it. It's your turn to do exercise 1E.